Due to exams, I think a lot of absentees here and there. So we can go ahead and get started.
So um, we'll have a brief about what happened last week. So it was mostly onto different types of galaxies and different types of nebulae. What all things are there across the entire nebulae family? All these things we saw. So you know me, you know Abhi, and all the other 10 friends of me, and we were seeing about what is a nebulae, how are they formed, different types of nebulae. There are stellar, emission, reflection, dark, planetary, and supernova. So just to give you a brief, we were seeing about how does the colors create in the sky, how does the colors come from all in the sky, which is a nebulae, that is the birthplace of all the stars. So comparing with hot and cold water, see the stars are formed in a very hot space, so they are very combustional and they burn and very fast and they move across the entire uh, the space of the universe, and they'll try to cover long distances. So it is like this. So it is like colors and colors of many things, and when they all combine together, they create a kind of a pattern. This pattern is called as nebulae. They are mostly made up of gases, and all these gases have certain kind of unique things. So some are made up of different types of elements, some are different types of gases. You can normally not cannot see all of them in one go, so you need to have multiple photographs of them in various spectrum. I told you about what is a spectrum. The spectrum consists of many different bands of light. So we have radio, infrared, visible, ultraviolet, X-ray, and gamma. So for example, if you take the Crab Nebula, each one looks different, but when you look very deep, you can find black holes when you look through gamma rays or pulsars or quasars. When you look through radio telescopes, you can hear what is happening inside the star, whether it is very active or is it very sleepy or very dormant. All these things you can find. So that is what we are seeing, and we were seeing different types of nebulae, how they form, how they get so many different kinds of shapes, what are the ways in which they are now expanding across the universe. All these things we saw in the last episode. So you are seeing what is a type of a planetary nebulae. Do they, why do they call them as a planet? All these things we saw. So different types of color, when they superimpose on one another, they become one big huge nebulae. So this is the Crab Nebulae, that is around 14,000 light years from us, I guess. So that is very far, but even if you still, you can able to visibly see it on the night sky. So today we are going to see something about how the planets are formed. Planets. So who are the planets? When we talk about what are the planets in our solar system, who are these guys?
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
These guys are planets. To the right are planets, and me and Moon are just friends. Moon is like a very small body. It doesn't come under a planet. So what makes it so? So this question I always used to ask. So I asked Moon. So how are they formed? So Moon was like, I don't know, maybe chemistry. Everything we bring in chemistry. So probably it is also something to do with chemistry. But Sun was very smart. Sun said it is not only ordinary chemistry, it is astrochemistry. Have you heard of this word astrochemistry?
Astronomy plus chemistry.
Okay. But can anyone tell me what is chemistry?
Chemicals.
Okay. What about Litika? Anything about chemistry?
About chemicals and science.
Okay, chemicals and science. Nitin? Okay, Nitin is very quiet. Okay. Lakshya?
Chemistry is a branch of physical science concerned with the composition, structure, and properties of matter.
Very good, super. So this all constitutes so many things. It comes under the umbrella of all the sciences. That is basically that's what we are going to see. So what is astrochemistry, if you can ask? It is something that becomes very big, very phenomenal when you study. When you're talking about Earth, you are bound to only find matters. That is like the matters that relate to hydrogen, helium, mercury, and all these very, very small elements. But when you look at this sky, when you look at out of our planet, when you look out of our solar system, it becomes very, very big. So I'll show you some very big science thing. Okay, this is a photograph. The one that you can see on your left is a photograph that was taken by a spacecraft that left Earth in middle of 1970s. So it took a photograph, it took a selfie of the Earth from a distance that is around 4 billion miles away. There it was just a very small dot. Earth was a very small dot. We are bound by gravity, we are bound by nature, and we are bound by sciences that are only dependent to our solar system. But from this distant, we are just a very small 1 pixel, one small dot. When you pick up a pen and you put a dot in a paper, that is the size of us when we look from that 4 billion miles away. Scientists were all wondering, okay, what may be the reason for us to find another planet or another star or another galaxy? So many things. So they devised a kind of 6 formulas. So these are all the 6 formulas. The ones you know is E equals mc squared. The one with Einstein says the tongue out. So the other things are motions of a body, that is the distance between two bigger objects, that is a sun and a star or a sun and a planet. The how fast the motion is. Then how close that a black hole is packed. It is also information paradox. There's so much of sciencey stuff. So these are all the 6 bounded cosmic equations. Okay. So now let's start from very basic. So you told me something about what is chemistry and what is basic chemistry. We'll start with physics. So physics is a completely a science of matter. So it is a matter, energy, and interaction between the two. So when you have a matter and you have energy, when you interact with each other, it becomes physics. That's one. Okay. Now I'm going to go even deeper and deeper into physics. Next is cosmology. Cosmology is the science of studying about origins of the world, origins of the universe, origins and development of it. It's all when the things that you can't touch with your hands, but you can see through your eyes. That is cosmology. Next is astronomy. That is the ones that you can look up and you can study about it using a telescope. That is the study of celestial objects. Next, even if you go deeper into it, you get chemistry. Chemistry is also a part of a study of matter and energy, but with the uses of different compositions. You know, okay, what's your favorite raga? What's your favorite raga? I think most of you like music. Okay, some kind of raga. Anybody?
What type of music you are asking, sir?
Any music, Carnatic, Western, whatever.
Nataswara.
Okay. Have you heard
Jazz.
of this raga called Amrita Varshini?
No, sir.
It's a cosmological raga which brings chillness and rain. Okay. Ananda Amrita Varshini, Amrita Varshini. In this song, the elements of water, wind, and air are combined together using this raga, and this elemental song creates a kind of chemistry. Okay. So when we study about elements that is combined through composition, either with using music or reactions of matter, it becomes something called chemistry, a structured way of learning thing. Next is biology. When you think of something that is living, it's a living organism. Who are we? What are we called as generally? What are we called as?
Human beings.
So human beings are living or non-living?
Living organisms.
So we are all living. So we come under biology. Okay. Next, if you go even deeper, there is something called biochemistry. So what are we made up of? What is inside our stomach? Can anyone guess? When you eat something, something breaks down in your stomach. Okay.
Glucose.
Glucose comes out from our body as energy. Okay. Inside our stomach, there is something called dilute hydrochloric acid. So when you eat something, the saliva and the food get mixed up, and when you go into your stomach, it gets gobbled up and it becomes kind of energy using acidic reaction. That is called dilute hydrochloric reaction. That is biochemistry. Okay. Next is astrophysics. When you think about things that are beyond us, but when you want to compare two things, that let's say like distance between two stars, distance between a planet, distance and interactions between a star and a planet, all these things when you come across, that is called astrophysics. If you go deeper into it, what is it made up of? See, our earth is made up of many things, but what is it mostly made up of? What is earth completely made up of? What is
It's mostly made up of water.
Okay, very good, super. So it is that is called astrochemistry. So when we take a telescope and look at another planet, what do we find as the color of water?
Blue.
Okay, almost right. Okay, so we find mostly different stars or different planets or different moons of different planets to have the blue color. It's supposed to relate to something called ice or water. That is astrochemistry. Okay. Next is astrobiology. The next big thing. What is our planets covered in 30-35% of its landmass? It is
Sir,
very green.
land.
Okay, blunt. Okay, what? It's also green in color.
Trees.
Correct. So trees. So when we look at something, when we look through this telescope and we find a different planet. So if you look at it, if you find a green color thing, it has to do something with photosynthesis or the organisms which are living using chemistry. That is what is called astrobiology. Next, even going deeper, astrobiochemistry. That is, if you start to find things that are reactive and which has some kind of elemental reactions as we know it, that is, we are all carbon based oxygen breathing animals. So if you find something that is also doing the same thing in a different planet, we say acha, we go there, we stay there, we'll be very happy. So this is astrobiochemistry. So all these things when you combine, so astrobiology, astrochemistry, astrobiochemistry, all these things when you combine together, it becomes a systematic study of astrophysics. So that's what we are trying to learn. So when we try to find what is the matter made up of, what is the planet made up of, we need to know all these things somehow. So what does astrochemistry cover? So we talked about so many things inside, one after the other: physics, chemistry, cosmology, biology, biochemistry, all these things. When you go close, what does it come into?
The molecules and the matters in other planets.
But the question is now different. It is, when does astrochemistry cover? So when are we right now? When are we in the time of the entire universe?
No idea.
No idea. Okay. I'll give you a clue. This is something that I told you long time back. That is around 13.7 billion years ago. There used to be some big activity. After that, there was a very huge explosion. After that, all these things happened. Something like that. Big. The clue is big. Very big.
Sir, can you explain the question again?
Some 13.7 billion years ago, there was something from which there became a very big kind of thing. Out of something, there came a very big thing.
Out of all the dust particles joined together.
No, there was a Damal-Dumil event, some 13.7 billion.
Big Bang Theory.
Yes, correct. So there is something called Big Bang Theory, which is there was nothing, that was around 13.7 billion years ago, and after that there was a huge bounding of light. That is a very big burst, and that burst created so much of things. So after that, everything moved across the space. Yes, what is your question, Sanita?
Sir, when the Big Bang Theory happened, the planet should be not round in shape, some irregular shape, no, sir?
Yes, that is what I'm going to come to. So we were all, that is called a planetary theory. That's what we are going to cover now. So imagine that you are all moving in a different time. Okay, now I'm going to tell you about the different times at which it is going to happen. Now we are going to start with the Big Bang. So planets come a little later. I'll tell you when it is coming. Okay. So the entire universe was starting to find its space, and all the hydrogen and helium are trying to move away. It is all moving across, and slowly they are becoming a very slow moving microwave background radiation. So they are slowly moving, and this is where chemistry starts to happen. So hydrogen, helium, damal, and all these things make into a very big shape, and they all form into something called as a stellar fusion reaction. This stellar fusion, this is also called as a star. So when this stellar fusion happens, the first generation of stars will come. So all these gaseous things, when they fall into each other, they become a round thing. That round thing becomes a star, and these round stars, when they slowly fade out, they become even different color shapes. So these shapes becomes a nebulae, nova, all these kind of shapes, and they move across the entire universe. So next, when they all come in together, they have to have some kind of bounding motion. I told you the most simplest shape in the entire universe is a circle, round shape. Remember, I showed you with a ball.
Yes, sir.
I took an ant and I put it on top of a ball and I asked it to go around. It will always go in straight line, but for it, its the reference is only a round ball. So like that, everything is around us and it is moving at constant speed across us. So that's how the gravity started working with one bigger mass and one smaller mass. For the ball, the ant, the ball is the center of the universe. For us, the sun is the center of the universe. For the sun, the universe is the center of the universe. So that is so big things to happen. So we'll all look into this one by one. So finally, out of all these things, some billion years after, around 5 billion years ago, we had the first break of our present day solar system. So all these things came into happening, and we have been very fortunate. From this time onwards only, Earth or other 9 planets started to form. So this is where our story comes in. So when you ask questions like who am I, why am I here, is there life out there, what's for lunch, all these kinds of questions will only come when you come into existence. That is life. So human life, as we know, had evolved from different kinds of organisms and life forms. From that, we have been very fortunate to ask very intelligent questions. So like you asking what is Big Bang, how far are we in the Big Bang, what is there in nature, all these things are questions that we've come out of intelligence, our human mind. So when we compare it, so with astrochemistry, which is all the bound way between 13.4 billion years from the starting point, we are now focused on something that is evolving, that is astrobiology, that is searching for life out of our planet. When we go out of our planet, we need to find some new planets to live. So that is called astrobiology. Chemistry is how things are happening in each planet, and physics is how different planets or different galaxies or different stars react to each other. All these things are the ones that we are going to study. So now coming back to our story, what is our planets made up of? How are our planets formed? Okay, I told you that the round shape, from when the Big Bang theory, when it was very round, very tight, very dense, so squeezed down like a chapati dough, it was very tight, and when you try to stretch it out, everything was thrown out. So but when we look it from our top, if you can try to look the universe from the top, it is very tightly packed and it is very densely packed. It's one straight line. It looks like one straight line. So where does we start? So we can compare it to our solar system. So we'll take the shape of the entire universe and now shrink it down to the size of our solar system. Okay, 13.7 billion years of time into a very small 10 billion light years. That is what maximum we can go for a heliosphere. So we start at the center with our sun. Next we go to our inner planets, Mercury, Venus, Earth and Mars, all our 1 astronomical unit planets, all our buddies, small buddies. Next we go to the asteroid belt, that is around 3 astronomical unit from us. And next our outer planets, Jupiter, Saturn, Uranus and Neptune, all are gaseous giants, very big guys. And next the oddball, that is the Pluto, and then the ones that are very far away, and most of them are made up of comets and other things. There are also objects that we don't understand, but they are also very round in shape and they go around in other round objects like our big sun. Okay, that is all in the Kuiper belt and the Oort cloud. So now I'm trying to bring you back to the planets and the shape of the planets. So now, have you ever wondered what is the orientation, that is the direction in which our planets are going down? I mean, going around.
Yes.
Okay. What is the only planet that does the belly roll?
Uranus.
Okay, so see, you can see the very small guy in the middle, almost in the middle, that is Uranus, and is always tilted at around 90 degrees. It is pointing towards the sun all the time. All the other planets, most of them are vertical, or either they'll be vertical from one axis or tilted in the other axis. Venus is the only one which is tilted on the opposite side, but most of them are vertical. They are rotating at their own axis, but in a vertical axis. Uranus is only belly rolling. So all these things seem to give us an idea that the sun is taking all the credit for keeping all the planets in the same point, in the same space. So this rotational axis that is moving of the planets across the sky is something very phenomenal that is found in every other planetary body or every other galaxy or every other solar system, whatever you find. So this is something round. So this is something always there be around. So why do they spin? Why do they have to spin at the same space? And why are some of the planets have a different orientation? Like Venus is on the tilted side, Uranus is on the horizontal side, Pluto spins always in a different axis. Say like it is going in the axis that is around 200 degrees in the inclined point. All the others are spinning in a flat disk. Pluto is going like this. Everybody else is going flat. The guys is only going in the opposite side. Why? Why are they different?
Because of the gravity.
Yes, gravity is one phenomenon. Also with that, there is some other bounding nature, that is the time for which a planet has to adapt to its surrounding. So all the rocky planets, because they were very close to the sun, all their atmosphere got a little less amount of gases. So they were only condensed to a shape of a very small shape. The other planets which were very far away had a lot of gas around them, so they tried to absorb them and they become very very huge planets. So all the Jovian planets like Jupiter, Saturn, Uranus and Neptune all become so big because they had a lot of free gases that was flowing around. So I will show you even a better picture. So comparing to all the 9 planets, you know that one of them is different from the other based on their type of location. So they are called terrestrial and Jovian because of the nature at which their surfaces are made up of. But why is that so? Because we ourselves are very curious. Yes, they have sent different rovers to different planets. I will tell about them in a short while. Okay. Kuiper belt and all the band in between the Jupiter and Mars is also that's called asteroid belt, has a lot of circular bodies. They are mostly made up of asteroids and other objects, dwarf planets and all these things. So they go around in a circular orbit. They form the gravity of the sun and they keep going around. So this is all very common. And there is also one big cloud of rotating masses, that is on the Oort cloud, that is very very far away. That is where all the comets go and stay there for some 300-400 years, and once their gravity is very strong and they are able to come back into our solar system, they fall towards the sun, and with that they'll start to burn away all their water and they'll have a very huge tail. That is what the Oort cloud is made up of, so many comets. So now we know the 4 basic things, that is every large body will follow an orderly motion across our sun. So the planets have 2 categories. They are very small planets or very big planets. There are asteroids and comets that are going out of our solar system and coming back and falling inside. Some planets have exceptional rotation, that is either they'll have in the vertical axis or they'll have in the horizontal axis. These are the 4 things that you find that is common in our solar system. Now there is a theory called protoplanet theory. I'll show you a very brief diagram of what is a protoplanet theory. So you have gravity that is acting on a sun, and this sun creates so much of gases across it and goes away in all directions. and you have heat and the light from a very big sun which heats away all the gases in the very close proximity. So from planets like Mercury, Venus and Earth and Mars, you have very weak gravity, so very much gravity, and lots of gases have escaped from the atmosphere.
Sir, in between you got stuck.
Okay, am I clear now?
Yes, sir.
One second, something to do with my internet connection. So I was telling you about the heat from the sun had taken away or ripped away all the atmosphere in our first 4 planets, that is Mercury, Venus, Earth and Mars, for billions and billions of years. That is around now the sun's age is around 5 billion years. So this 5 billion years, all these 4 planets had different kinds of atmosphere and they were slowly going away. So with that, we know that the metal, rock, gases and ices have formed in a dense pattern. That is the first one. Next, all the other outer planets, that is the planets that are there in Jupiter, Saturn, Uranus and Neptune, have become accretional. That is, they have collected all the gases. They took a straw, they took off all the gases in the surrounding and they become very huge big planets. So those that have left out materials, they become asteroids, and those that are not able to form into a very big planets, they become Jovian planets. And those that are very, very far away, some very huge, thousands and thousands and thousands of kilometers away, they become comets because of gravity. So imagine that from the first 100 billion years, all these things were in the form of very dusty thing. So when they start to go around and around, they started to fall in action. So this is the first one, second one, third, fourth, fifth, sixth, seventh and eighth. So till about the first 4 times, they were only going around in circle with no action at all. They don't know where they are going. Where are you going? I'm just following a big thing. That I'm going. So everywhere it is going around. So after about this point, they become a very densely packed planet. So this is how it looked like. So for the first 1 billion years, no planet had a very good surface. They were very hot, boiling planet. So they were very dusty, they were very rocky. Then they started to form very small embryonic planets. They are called planetesimals. And then they become planets. So this is the actual shape. So we came to know this using studying different kinds of astrochemistry and astrophysics of all the other planets. So a quick reminder. So all these things, that is from the Big Bang to the formation of all the stars, to the formation of a solar system, to the formation of our planets, to the formation of our life, everything has to take a long period of time. So everything happened over some 13.7 billion years in time, and all of us are just very small dust, very small dust in the entire cosmic universe. So this is a very brief about all the interstellar clouds and all that we have. So even you breathe, the oxygen that you breathe has come up from some distant star that was dying some billion years ago. So we saw what is astrochemistry, we saw what is Big Bang theory, we saw what is the formation of planets. So this is it for today, and the next week we will be seeing what is a neutron star, what makes it so special. So that's it for today. You have any questions, you can ask me. I think there was one question. Yes, your question.
Why there is no air in space, sir?
Why there is no air in space? Because the amount of air that we breathe is all dependent on the volume that is surrounding us. Okay. Have you ever tried to take a tumbler and put it into your mouth and start to suck the tumbler's air?
Yes, sir.
What will happen after some 20-30 seconds?
It will stick here.
Okay, it will stick here. But what happens inside?
There will be no air to breathe.
Okay. What will you do? Do you still breathe through your nose, or do you still not breathe through your nose?
Still breathe.
Why?
We need to breathe for living.
No, that is fundamentals of life. I'm asking about what is happening between the lungs and the tumbler. What is comparatively happening between the lung and your tumbler?
The oxygen inside the tumbler is taken through lungs and it's given out as carbon dioxide.
Okay. So all this time the air is in the constant pressure. It is in constant pressure. So when there is no air to escape, it stays there for some time. So there is no pressurized air in the outer atmosphere. So if we go and try to breathe, the gas or the air stay in one place. So it will try to move around. So when you have a breathable apparatus, say like a mask or an oxygen mask, only then you can. Without that, you can't breathe. Okay. Yes, Lakshya, what is your question?
So my question is, what is the first planet discovered with the aid of a telescope?
First planet that was detected was Saturn came very early. Saturn was like they were seeing it through a normal lens. But telescopes, I think the first one was uh, Neptune. Neptune was discovered in 1785. It was when optical telescopes came into life.
When was Saturn seen, sir?
Saturn was seen by Galileo Galilei. That was in the year 1600, 1645 or 16.
The first planet to be seen is Saturn.
The first planet to be seen through an observational telescope was Saturn. Yes. And Galileo Galilei had a very unique way of drawing all the Jovian moons and Jovian patterns. So he was taking a very big diary and he was drawing and he was taking dots whether what was his name. So he named around 16 moons of Jupiter and Saturn by the time he was looking through the telescope. So he did not know that he was looking at another planet. He was thinking that he was looking at another sun or another galaxy. But slowly he started to understand that it has to do with something called a planet. Okay. So did scientists send rovers to outer planets? No, not yet. Rovers, only one had landed on Titan. What is Titan? Where is Titan?
Is it the moon of Saturn?
Okay, good. So there has been only one rover. That is not rover. That is a lander. That is called a lander that had dropped on the moon of Titan. Sorry, a moon of Saturn called Titan, and it is being active for only I think 2 months. It was there only for 2 months, and after that, it got the battery got drained. All the battery got drained.
Is Titan bigger than the Earth?
Yeah, come again, Kanama.
Is Titan bigger than the Earth?
Your voice is breaking so bad. I think my internet is breaking. You can type. You can type. Hi, Nitin. Nitin, so sad because we did not have the helicopter go around in Mars last week. Called it Ingenuity, right? The Ingenuity helicopter did not go because there was very bad weather. Lots of heat wave and lot of night temperatures are going down in Mars. So they did not spend the helicopter around in the Mars. Remember that helicopter, very small helicopter?
Yeah.
This week. So probably next week or the week after they'll fly. Is Titan bigger than Earth? It is slightly bigger, I guess. It is slightly bigger than Earth. I remember.
And why is it not kept as a planet, sir?
Good question. Only those that follow orbital paths across the sun is called a planet. Those that revolve around another planetary body is called a moon or a satellite.
Why are stars far from us?
Okay, when you imagine we are we are in the fifth standard. We are in the fifth standard of our school, in the school of solar system. But the other stars are in the 8th standard or 9th standard or 12th standard in a different section. So they are quite far. They have grown old. They are very older in their older classes. So once we start to get bigger, probably we can go very near to another star. But that has happened very, very rarely. Only if say like very collision, that is when two stars try to collide, it happens, that is they come very close to each other. What color is the universe? That is when we observe the universe through our telescope, that is using our radio telescope, there can be of only one color, that is redshift. You know what is redshift?
No, sir.
Okay. It is mostly observed to be in the color of redshift because all the objects are moving away from each other. So very rarely do they come very close to each other. So all the stars are going away from each other. All the planets are going away from each other. All the objects that are going around our object's center of our galaxy is going away from each other. So that's called redshift. So something is pulling each of us apart. So that's why the theory of Big Bang theory is there all through our life. Something is pulling us apart. It's like a very big, you know what is parota? Parota, eatable parota. So
Yes, sir.
it's like stretching a parota. Parota dough. It is trying to stretch it. It becomes very big. It's like a rubber band. So no point at which it will come back. That is called a different theory. It's not called a Big Bang theory. It's called pulsating theory. It's also a different theory that scientists are speculating. They don't know whether it is true or false. Any other questions?
Okay, sir.
So what are we seeing next week?
Guessing about neutrons, sir.
Oh, very good, super. Do planets grow? Interesting. When do you want the planet to grow? No?
I want it to keep on growing.
Okay, there is only one way in which a planet can grow. The planet can grow only if it is a very young planet. If it is a very old planet, it cannot grow. I told you about planetesimal and dust and all the gravity pulling it into a very small chunk, correct? That happened like 4.5 billion years ago. So by that time, the very small chunks of rock join together and become a very big round thing. That is the time when planets grow. Okay, has Amma grown in your last 10 years? Has Amma grown in height?
No.
What about Lakshya? Lakshya, Amma, Ramya ma'am has grown in the last 10 years?
Little bit, sir.
A little bit, okay. That is very nominal. That is very, 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 very minute. So compared to you, children are in the growing age between 1 to 18. Between the age of 1 to 18, you will start to grow. So from the height of 2 feet, you will go to the height of 6 feet or maybe 5 foot 11. Like that, you will grow. That is the growing phase. Planets only grew when they were very young. Now all the planets are old. From Mercury to Neptune, every planet is very old. So they can't grow anymore. If they grow, they will only hit the ceiling.
So what is the first planet to be found in our solar system?
First planet, Venus. Venus was the first planet. There was a theory that even the Romans and Greeks had named it as a very beautiful planet. Venus was the first planet to be discovered. Yes, Lakshya, what was the question?
What will happen if we pour water onto the sun?
What will happen if we pour water onto the sun?
That will require a lot of water.
But still, that's a very good question. How much amount of water do you want to pour?
1 bucket.
1 bucket, it will not. It will quickly
That doesn't
evaporate.
react.
It will quickly evaporate. You do one thing, okay? Do you have snow right now in US?
No, sir.
Are you in plans to go and see snow in the next couple of weeks or something like that? No.
It's spring now, sir.
It's a very bad thing. So you can't see snow. Okay, next time if you see snow, what you do? You take a tumbler of hot water and you throw it into the air. Okay, you go outside and throw it into the air. See what happens. Okay. Any guess you can feel what will happen?
The water will melt.
Water will it will not.
Sir, the water turns into ice like.
Almost there, but there is a different word I am expressing. There is a different word for it. Water becomes what?
It turns into water vapor.
Correct. That's right. So it turns into water vapor. It turns and it goes into a form of kind of white color cloud. So you can try. You can go outside, take a tumbler of water, form the snow. It will turn into white smoke. Or it becomes white water vapor. So for that, if you need to go and go very near to the sun and you have to start 1 bucket of water, you need to pour at least some very close to the surface of mercury, and then you have to throw. That way only it will become evaporated. Yes, what is your other question?
What will happen if we pour lots and lots of water on the Earth and other planets?
We need to find a source like that. Probably if you put lots and lots of water or all the surface, they like your home, my home, Litika's home, Nitin's home, every home will get into. So you need to swim to your school or you need to swim to your home all the way from between. So our earth is only able to hold some little bit of water. It can't hold more amount of water. If you hold more amount of water, then the whole planet becomes very tough to live. It will become a water world. It's like a theme park. You have to learn to swim a lot. Do you know to swim? Can you swim? Hey, yo.
Yes,
No.
Where does the universe begin?
Sorry, Kanna, what did you say?
Where does the universe begin?
The universe began when there was a big bang, probably that 13.7 billion, but we don't know the exact location. It's like asking where is the starting point of today? What is the starting point of today? What is today? What is starting point of today?
12 o'clock.
That is time. Time in relation to yesterday. So when yesterday ended, today started.
What April?
That is the date. So we are only knowing what is bound by our nature. That is, we can compare one thing to another. So we know that the date starts by 1. We know the date starts by 12 a.m. And we know that the date starts by a time that which we have crossed the same spot some 365 days later. So all these things are comparative. So we don't know where to compare the start of a universe. So where did universe begin? Nobody knows. Okay. So that's it for today. Any more questions?
Yes, sir.
Okay. Bye bye.
Bye, sir.
Bye.
Bye.
Bye bye.
Sir, I have one last question, sir.
Yes, sir.
If you go down. If the universe turned into a tiny dot,
Okay.
has anyone ever seen the universe in a tiny dot?
Anyone has ever seen the universe as a tiny dot? It's a theory. Okay. We know that the origin of a universe started with some kind of action. Okay. Say, okay. When did you reach US? When did you reach America?
In January 27.
So January 27, you started from Earth on the you started from Chennai airport, right?
Sir. Yes, sir.
Okay. From Chennai airport, you flew to another location and there you boarded another flight and you went there to US, correct?
Yes, sir.
So there was a time where you were not knowing whether in which direction you are going, whether you are going towards the sun, away from the sun, or closer to the sun. Had you had that experience?
Yes, sir.
So all these things combine with only one small question. So when scientists look through a telescope, when they look at small things, they are bound to find moving in a very constant speed. So they are moving in a direction that we are expected it to move. So when we try to trace back, so Lakshya started on January 27th. If you rewind time. So if you rewind the light from Lakshya, from her mobile phone, or from her train, of her flight ticket, or from her luggage, all these things, if we go back in time, we can know that the origin point, that is the starting of destination, was Chennai. Correct?
Yes, sir.
So like that, when you try to find the origin of a planet or origin of a galaxy, everything starts from a point. That point is where scientist is trying to look. It's a very big universe. If one person starts to look at one planet, it will take at least say like a billion people to look at every planet across the universe. Correct? So we don't have that many scientists. I think Lakshya should go and become scientist, and Samyukta should become a scientist, and Nitin should become a scientist, so that we can go and find all the clues and answers. Okay?
Yes, sir.
I'm gonna become an
And one
aeronautical
question
engineer.
is very
Yes. You want to be an aeronautical scientist?
Yes, sir.
Sir,
I want to become
I
an
had a
aeronautical
question which
engineer.
was very
What was your question, Kanama?
I had a question which was very curious. I really wanted to ask you that which is the next rover which is going to Mars,
Okay.
and what year or date?
That is planned on the year 2024, 2024 or 2025. I'm not sure. That is
Yes.
that is based by the European Space Agency, ESA. So they are going to send a rover to collect all the samples that has been collected for the next 2 years. So 2021, 2022, 2023, all these 3 years, they are going to find a lot of samples in the Mars surface across Jezero crater and all the locations that they have sent the rover to find. So after that, there is going to be a return sample mission. That is going to happen in 2024. Yes.
Nitin has a question.
Yes, please.
What will the next moon form in the solar system?
What was the?
No, he's asking when will the next moon form in the solar system?
When will the next moon form in the solar system? Interesting.
Good job, Nitin.
Okay, I'll give you one example. Okay, say there was like a very huge asteroid. Okay, there is a very huge asteroid. Okay, that's in the size of our moon, that is crossing between Earth and moon. Okay, suddenly it was very big. It was a very big rocky asteroid. It is crossing the gap between Earth and the moon. And suddenly what happens, it is looking at the Earth and it's saying that this looks like a nice place, can I land on it? What will happen? Boom. That's what will happen. It will happen and it will become boom on the moon. So for a planet to capture a moon, it is very tough. For the Earth to form another moon, maybe it will take another billion years, but there is a possibility that we can capture a very small asteroid and it can become a second moon. That is possible. That is quite possible. See, Mars has 2 moons, right? Deimos and Phobos. They were both asteroids. They were not a regular planetary round-shaped moon. So probably we can capture another moon like that. Or we can go and pick up one from Jupiter. Jupiter has more than 90 moons. We can go and usurp one from there and bring it to our planet, and we can keep one moon for us. That's the best way to have our own moon, second moon. So we'll name that moon as Nitin Moon, Moon 2, Nitin Moon. Sounds good? Sounds good?
Yes, sir.
Okay. Chalo, you go and sleep. Good night. Bye bye.
Not good night, good morning.
Okay, yeah, good morning. For us, it is good night. Bye bye.
Bye, sir.
Bye, sir.